So I don't know if you already signed up for the Google Calendar and the mailing list, but if not, totally do that. I have to put that out there. And then yes, sign up for the Distinguished Lecturer event. So just to recap, so if you haven't downloaded it, I don't know if you did. I know some people last time did not download it, so just want to go over it. So to download EEG Lab, you download the compressed zip file. I have the link under download EEG Lab where you can just access that. Then you start MATLAB, you set your path. There's various ways to do that, but the easiest one, well, actually, that's described, I think, in the first lecture. So if you need to, just go over what Christian was talking about. He did a really good job on it. And then type EEG Lab into the command window, press enter, you're good to go. You're going to get a GUI pop-up, looks just like this. This is the EEG Lab. You can code everything if you wanted, but because we already got this nice GUI, we're just going to use it. And then, so last week we went over pre-processing. So this is the pre-processing pipeline. So you collect data, you import it, and then you have to re-reference it, downsample. You could do filters to it. You want to remove the noise, the artifacts, and then you get rid of the bad channels as well. I know we have not touched base on ICA yet, or run or reject components. I think that is next week. We start the actual signal processing of it. Right now it's just pre-processing. And then down below, there is a link to the pre-processing series. It goes through step-by-step kind of each of these little markers. So if you think that I don't explain it well enough, this is another like outside source for you, right? And then just in case you forgot, or I don't know if we went in depth on it, or I just want to touch base on it. So the little menu icons at the top of the EEG Lab GUI, these are what they all mean. So if you're looking to do something like, let's say like remove noise, then you know generally where to go just based on what these individual things do. I know for the study one, it's not going to be available to you unless you create a study. I don't quite know what creating a study is because I only have ever worked with the data that comes with EEG Lab, the sample data, and they don't have a sample or they don't have a study for that. So when I do, I will share. Also, if you did want to code, like I mentioned before, there are MATLAB functions that, and a link to it that kind of explains how to do it. It's up to you, really. I think this GUI works really fine, but I know some people who are more computer-based probably prefer to just kind of code it, but I don't think bioengineering is super rigorous on coding to the extent like computer science is, so I think a GUI would suffice. And then so for plotting, most of the things we're going to do is a regular plot. All you have to do is you have to go to plot on the main menu, right there. And then you hit channel data scroll. And then if you want to do a spectra in map, you have to go to plot and then hit channel spectra and maps. This is something we haven't worked with yet, especially in just the pre-processing phase. This is, so example of it is the image to the right. So it shows you the different peaks and it shows you like the gradient map. The only thing with that, I think that needs the MATLAB signal processing package. I think that's supposed to come with downloading EEG, but I'm not quite sure. So that's something we'll touch base on either next week or the week after. I forget who is presenting next week, but they'll have more information on that then. But for the rest of this tutorial and then the previous two tutorials, we're just working with the regular plots. So you're going to do plot, channel data scroll. Importing data. So for this tutorial, I'm just using the sample data. So what I do is I hit file, load existing data set. Otherwise, you do file, load data. You're going to load a set file. I believe the set file comes without the epochs. Epochs we'll again touch base on next week. So that's something to think about when you do start actually loading data instead of using the data set given to us. And then for more data sets, aside from just the sample one, I also have a link that kind of shows you like, think of it like NCBI, but for neural data, right? And let me show you really quick. So is this screen sharing? Can you see the MATLAB?
I can't see it.
Okay, give me a second then. Right, so we are in our path, right, all the way to EEG lab. So all I have to do is type EEG lab into the command window, and the GUI will pop up, and then I will show that. All right, so file, load existing data set. You do EEG lab data set, or EEG lab data.set. This is the epoch file. We don't need that for the purposes of this tutorial. Now, okay, so it's loaded. And then I'm going to continue with the presentation. Okay, so generally how you change the image on the data window. So if you want to magnify the EEG data, like scaling it, right, by like a factor of 2 or maybe a half, all you have to do is in the box right here, if you could see my cursor where it says 100, you just input a value and it'll scale it to that. So the default one is 80. In this example, I changed it to 100. You can change it to whatever. Otherwise, if you don't want to enter it, you could just toggle it. I'll show you that as well. So plot, data scroll, and then we have this, right? So it's scaled to 80 default. And if I want to scale it to 100, looks like that. If you want to scale it to 1, it becomes indecipherable, right? You're just way too close to it. So 80 is a good default. 40 is probably not the best. I stick with 100, but you can do whatever you prefer. 80 is fine. And then if you wish to stack the data, so you just kind of want to see the general trend of all of the channels, you hit stack, and it just weighs it there for you. And if you want to normalize the data, you hit norm, and then it'll normalize it for you. All right. And then changing the y-axis. So from the previous plot, you can see, or previous graph, you could see that we see all the channels right there. Another way of kind of getting a better picture of individual channels is to change the y-axis. So how you do that is you go to settings right here. When you have your plot, you go to the settings on the top, and you hit number of channels to display. At first it was 32. I brought it down to 1, 2, 3, 4, 5. So it's displaying 5 complete channels. POZ at the top is not a complete channel, so you see the very beginning of it, but then it tends to taper upwards so you don't see it. You can change that again to anything you want, but at least now the data is clearer, right? So again, I'll just show that in MATLAB. settings, number of channels to display. Let's say we're going to do 10. So it displays the 10 channels, and the square, 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 those are events. So I forgot you missed last lecture. So events are things that happen that then a person will react to. For example, an event in this scenario, I think they used, they flashed a user had to look at a screen, and they had to look at this one corner, and when it like a green square flashed in the corner, they had to press a button, okay? So them pressing the button is represented by the red line, and then the square being shown is represented by the green line, which says square. So for this time interval of 5 seconds, you can see that they only hit the button once. Then you can set your grid here if you so want, just to kind of cover things from last lecture as well. And add a title, so we'll say sample data EEG lab, pops up at the top, and I think that's kind of all we really can do. You could do other things if you want, like again, you could stack, you can normalize it. All right. And then, so changing the domain of it then. Domain is in seconds. So from the previous one, we were in a 10-second kind of window. If you want to make that a second, or you can make it 20 seconds if you want. All you have to do is hit settings. Oh, wrong one, sorry. All you have to do is hit settings and then time range to display. First, I'm gonna turn those off. Settings, time range to display. So right now I am in a 5-second window. Say I want to make it 25, right? Then that's what it looks like. Although that's kind of unclear, so it might be best to reduce it down to, I think the lowest I've gone is 2 seconds. I think it gives a pretty decent picture. That might be too low depending on what you're trying to get out of the data. Maybe 4 would be fine. But I mean, when you have a clear thing you want to do with this data and probably not using the sample data, you can kind of define that for yourself. So adding the title, you do display, hit title. I did just show that. Although if you want me to go over it again, I'll go over it again later. So it looks like that right there at the top. And then importing channel location. So this is really useful if you want to do source localization, which is trying to identify where, in the brain a specific activity originates, commonly called inverse mapping. So you have EEGs, right, on the patient, subject, whatever, and you're trying to find out what happens when they look at a picture, right? Like where in the brain is that happening? So what you do is you inverse map it. It's kind of hard to explain without showing, so I'll try showing it to you. So you edit channel locations, use MNI coordinate file for BEM dipfit model. That being said, I think on the most recent version of EEG Lab, you don't have to do that. I believe it is already using M&I coordinates. I know, I forget how many times I played around with it, so I don't know if it saved mine, but I believe it is just straight an M&I coordinate. And then if you don't have a file, you have to put it in manually. If you have a file, press cancel. So for this example, using the data given to us, we do have a file. So then we hit cancel, and then in that same pop-up window, you click read locations, and then you select the format. Although, I'll show you actually. That's not what I want to share. Here we go. So edit, down to channel locations. This pops up. So in here, it already has all the M&I coordinates in there for me. Go down to read locations right here.
I can't see the pop-up.
Oh, my bad. I forgot to share that again. So this pops up, right? And then right here under the FPZ, right, those are all the coordinates. It has polar coordinates, Cartesian, spherical. So it's really defining it in a 3D space. And then go down here to read locations, like above the help button. You hit that. So you're in the EEG lab folder. You go to sample data, and then you hit EEG lab Chan 32 locks. So you're trying to get the locus, which are like the locations of things, things being the EEGs. And then this pops up. You hit auto detect. I haven't played around with the other things. I'm not quite sure what they do. That would be fun, I suppose. It's just kind of what type of file format do you have? You can specify it if you want. I know the dot locks supports a number of different files, I believe. I don't have them on the top of my head, but you can choose the format, or you can just have the program choose it for you. Hold on a sec. Okay, so then we come back. I was wondering that went away. So you come back here, and you've already read in the data now, right? Okay, so you can either view this 2D or 3D. I'm kind of getting ahead of myself. I'll touch base on this in a hot sec, but just want to show you since I'm here. So plot 2D. So you get this, and it's showing you every single electrode that is connected. These, the EOG1, EOG2 represent the eyes, I believe. And you can click on each electrode and see the number it is. So these are all the channels. Similarly, for your plot, you can change it so it's not the name of the electrode, it's the number of the electrode. I'll show you that as well. But then I also want to show, all right, so then across from the 2D, there's the 3D. So plot in 3D. Oh, and you get this. So you get this. So this is showing you the general map of the plane or the brain in the XYZ coordinate system. And then on all of these figures, if you wanted to, if you're, say you're writing a paper and you need to include this figure, you can save it, right? Save it as a PNG file. Maybe not a PNG file. They got, oh yeah, PNG file, JPEG file. MATLAB figures, I don't think paste well into like Word. They might paste well into Google Doc, I don't know. And you can also insert the XYZ labels. So say this is, gosh, what does that represent? I think it's hertz. Yeah. Hertz. You can create the image to your liking. Helps a lot, especially if it's like for an academic thing, you know, like research paper, homework. I don't know when you would use it in homework, but if you do. All right, so that's how you import channel location. Just as I was just showing you. So that's the 2D plot, the 3D plot. And then you can also reject data. So you can do this 2 different ways, I believe. 1 different way, 2 different ways. So the first way is to reject by the region. So that's if you're looking at the plot of the data and say you're well-versed in neurology and neuroscience, which you're a neuroscience concentration in BioE, which makes sense, you very well may be, I am not. So say you're looking at the EEG and you can see very clearly that there's an artifact at a certain place. You can just take that out without having to do any kind of like statistical analysis to determine that's an artifact, things of that nature. So to do that, you go to the main EEG GUI, hit tools, and then go to inspect/reject data by eye. From there, you hit just continue. You highlight the specific region you want. So how to highlight is you click at a certain X coordinate that you want to start at, and you drag over to the other X coordinate. It doesn't matter at what Y coordinate you're in, so long as you're at your X you want to be at. And then to unhighlight it, so say you highlight and you're like, oh shoot, I don't want to highlight that's not the artifact. You tap it once, it goes away. So it's really easy to kind of like reverse or undo something. And then you click reject and it's gone. And I'll show you what that looks like. So when you highlight the data, it looks like this in this like teal box, right? For the purposes of this like demonstration, I just chose to go from the 3-second mark to the 4-second mark because I don't know much about neuroscience and it seems like the busiest place in the like the plot. So highlighted it and then went through the steps I just talked about where you go to tools, inspect/reject data by eye, continue, highlight, reject, and then the plot on the right is what you end up with. So it has a very definitive line that is marked with the word boundary that shows you where you then took out that piece of data or all those pieces of data, and then you put the signal back together, right? So I'll show you what that looks like when you actually do it. Okay, so tools, go down right here to inspect/reject, click that. That is okay, so you hit continue. So this is your data now, and I'm gonna highlight the same thing. So I'm gonna start at the 3-second mark, go over to the 4.
Show the plot.
Oh, shoot, right. Okay, perfect. So I went from 3 to the 4. Want to undo it, I click it once. Say I want to get rid of from the square at second 1 to the next square, or the event at second 1 to the next event. You highlight, drag over. And like I said, it doesn't matter at what y coordinate you start dragging over. It just matters at what x coordinate you're at. So I'm going to start at 3, go over to where I think 4 is. Right, and that is where the artifact is, I'm saying, for the purposes of this. So I'm happy with it. I'm not going to unhighlight it. You hit reject. And then you get this screen. So this screen is you saving this new plot as something. This is so if you ever want to go back to the original plot, you have it, or the original data set, I mean. So we're going to call this continuous EEG data reject, because it shows the rejected, well, the rejected region is out of it. And then it pops up another window. This time, instead of being number 1, it's number 2, and it tells you which data set you're using. So it's number 2, continuous EEG data reject. You go to data sets, you can easily just toggle over to the first one. And so we're going to go over to the second one. Plot it, channel data scroll, because we're not doing spectra and maps yet. Then what you're left with is this. And again, you could stack, normalize it, whatever you would like. And that is how you do that. So, where am I? Okay. So, filtering data now. Instead of just taking out the data by looking at it, you can filter out certain types of data that you're not looking for. So that looks like doing low pass filter and high pass filter. I know if you've taken 240, Esmo Behe or whoever taught it at the time went over it probably pretty extensively, since that's the signal processing class. But just generally, this is how you do a low and high pass filter. So low pass filter, you go to the tools menu from the main EEG GUI, hit filter the data and do basic FIR filter. From there, it's going to pop up a screen where you can enter in a value for the high frequency and a value for the low frequency, right? So you're filtering out low and high. For the purposes of the low pass filter, you obviously enter in a value to the low frequency range. So for this, I entered in the frequency of 1. So then it shows the plot of the magnitude and the phase. And then high pass filter, I think I chose 4 or 5 for the high frequency. I think 5, 4, I think 5. Same process, tools, filter the data, basic FIR filter, and then just fill in the high frequency range. Now, if you're trying to do a high and low pass filter, you're not going to want to do them in all in one swoop. So when it does pop up the menu, you technically can enter a value for low and high pass, but sometimes that results in the filtering not working. So what you should do is you should do a low pass filter, save that just like we did with the rejecting a part of the graph, the artifact. So it saves 2 versions of it, the one before, the one after. So you have the one without any filtering, and then the one with the low pass filtering, and then the one from the one with the low pass filtering, you then reapply, or apply again rather, a filter, this one being a high pass filter. So doing that. All right. All right, filter the data, basic FIR, new default. So lower edge of the frequency bandpass, let's do, well, I'll do one just because that's the one I did in the PowerPoint. I'll show that. So this is what pops up. Lower edge of the frequency bandpass, higher edge of the frequency bandpass. I'm entering 1 for lower edge. You can change other specs of it. I have not. I think that's a little like upper level type stuff, but hopefully eventually we get there and that eventually we'll do more about it. But for the purposes of just basic knowledge on preprocessing, I'm not going to touch it. So we're going to stick with the 1, low pass. And then we get this, right? And then going back. Go to tools, filter data, basic FIR, higher edge, let's do 5. Let me see if I did 5 or 4. Okay, so I think I did 4. Well, anyways, this is how you do it with the bandpass or high filter or high pass filter of 5. Right. And I'll show you. Go to tools, so filter data. We're going to do both a high and low pass frequency. So I'll do 2. I'll do 2 and 4. So in this case, it worked. If you deal with like multiple data sets, it's probably not going to work. Or you do some kind of like weird frequency range. All I know is that sometimes it doesn't work, sometimes it does work. It's probably just better practice to do the low pass and then the high pass. Just save it as you go on and don't do what I just did. I think that might be it, actually. Let me see. I know I could pull up if you wanted to, because I know you weren't here for the past one, what Nisha was talking about. She went more in on like the sampling, resampling, the referencing, which is, referencing is, so, all right, hold on, there's a purpose to this. So referencing is like, if this is the top of your head and you have EEG channels, right, everywhere, say you want to have your reference channel be the one that's right here, right? Re-referencing is just saying, well, now I want it to be this one, right? She goes through the process. I did not, just because I assumed there were going to be people here from the last one. So I didn't want to like go over everything she went over, because she did go over a lot. So let me pull that up and I'll go through that then. So this is what Nisha went over last weekend or last week, just to kind of give you an idea. So she kind of talked about what pre-processed data is, right? Pre-processed, or rather pre-processed data uses the raw unprocessed signal from the recording device, right? You can do filters to the pre-processed data, but I know the signal analysis does more. She talked a lot rather about the pre-processed pipeline. So she went through it kind of like how I did, where she went in like sequential order, kind of how you go through that. I think she went over it in a little bit more of a defined manner, but I didn't want to bore people. Okay, bye, Christian. So first you import and import into EEG Lab. So she's talking about that there are other toolboxes, which is true. I was trying to show a cohesive kind of example from just using the sample data set. So if you end up going to one of those database websites and you want to use another toolbox, this is generally how you'll do it. If you want, I will throw into the chat in a jiffy the YouTube kind of playlist that goes through this. It is through EEG Lab, it's their YouTube channel. Then you import the event markers, channel locations. Right, import from data channel. Forget, she was elaborating on something here. This is seeing all the event channels, and then it has the amplitudes. If the amplitudes are the same, they'll be the same color. In this case, the second and third are, I believe. And then inserting channel locations, that's a little bit what I've talked about. So this is the drop-down menu where you would use MNI coordinate file for BEM dip fit model, which is what I was talking about. Although I think in the version of EEG Lab, I don't think I remember doing that. So I think yours is just going to be like already in the MNI coordinate system. I think you probably make it BESA, but I know EEG Lab did highly recommend that people use MNI. So I think they eventually just kind of made that a standard, but don't quote me on that. If you want to try it, let me know. I'll kind of like troubleshoot it, or you know that it's the MNI coordinate selection one. This is changing a lot more specs. So you can kind of change how you view the individual's like skull, right? Re-reference down sample. So re-referencing, you go to tools, you just hit re-reference, although I'll show you what that looks like in EEG Lab right now. So tools, reference the data, compute average reference. Yeah, let's say we'll compute the average. Oh, let me show that. So when I hit tools and reference data, re-reference data rather, I believe, it pops up this. We're gonna just compute the average reference. Forget how she checked that. Honestly, I was so busy kind of preparing for this one. I forget what she was talking about. Well, if you want, I can get her to send it to you. I assume you could probably figure out most of this, but I'll try to help you, you know, as you go along. Did you have questions on anything I presented aside from the lecture from last week?
Nope.
Cool. All right. I'll talk to Christian about putting the video on YouTube. Go to YouTube. We are engineering and medicine and biology side of UIC. Here we are. We got the making waves one. And let me just drop in really quick these links in case you want them. I'm gonna stop the recording.